So we've been talking about this library that we've created called Baby Pandas. It's a smaller version of Pandas. So let's see more of the functionality of Baby Pandas today. So we're going to import this by running import Baby Pandas as BPD. Okay, last time we were taking a look at a particular data set of NBA players and their salaries. And we said that this was stored in what's called a CSV file. That's comma separated values. And we have this handy function, bpd.readcsv, which will read that into a table. And then we'll set the index, set the row labels to be the player names. That's what we're doing here. Okay. So last time we saw how to answer questions like, what was the biggest salary? We can use .get the salary column, and then we can .max. How many players were there? We can ask for the shape of the table. What was LeBron James' salary? There we would get the salary column, and then we would .loc LeBron James. And then who had the biggest salary? There we sort the table, either in ascending or descending order, and then we take the index, the first entry in the index, if we sort it in descending order, or the last entry if we sort it in ascending order. But there's still a lot of questions that we don't know how to answer yet. For example, who was the highest paid center? Center is a position in basketball. So which of the centers was the highest paid? What is the total payroll of the Cleveland Cavs? What team had the largest combined salary? So we don't know how to answer these questions yet, but we're going to see how to do that today. So the first thing we're going to look at is selecting a subset of the table's rows, or something that you might hear called querying. So think of that first question, who was the highest paid center? So if we look through this data set here, there are 5 positions in basketball. Center is one of them. And the centers are kind of like interspersed in our data, and we're interested in figuring out which of these centers was the highest paid. So the idea is that if I had a table that consisted only of centers, I would know how to do it, right? If my table didn't have all of the other positions in it, it just had the centers, I could do it. And the way I would do it is I would sort and then look in the index for either the first or last player name, depending on whether I sorted in ascending or descending order. This is just a special case of the problem we solved last time of what player overall is paid the most. So the question is, how do I get a table with only the centers in it? And that's what we're going to do right now. Okay, so here's the solution. I'll just write the solution first, and then I'll describe what's going on here. So the way to kind of read this is I'm asking for only the places where the position is equal to C, and then I'm going to return a new table. And then I run that, here's the table I get. And then I can use this table to answer my original question. But let's talk a little bit about what's going on here. So we've talked a little bit about Booleans. And if you want a refresher, the textbook has a good section on Booleans. So if I do a comparison between two things in Python, what I get back is an answer true or false. So what I'm doing here is I'm asking Python, are these two strings equal? Is PG equal to C? And remember, we use double equal signs to test for equality. We use single equals to do assignments. Okay, so if I run this cell, you can guess what's going to happen. It's going to say false. These two things are not equal. Okay. On the other hand, if I check for C equals C, it'll say true. These two things are equal. So what do you think will happen if I take all of the salary, or all of the positions from the table? Okay, so I get a column of every player's position. And remember, columns kind of act like arrays. And I ask, are the positions equal to C? Well, what happens is you get an array back, or a series, to be precise, where every entry is determined by checking whether or not that player's position is equal to C. So if I look at my original series here, okay, you can see that Paul Millsap is a power forward, Al Horford is a center, Tiago Splitter is a center, Jeff Teague is a point guard, and so forth. And you kind of compare that to what you see here. Remember, Al Horford and Tiago Splitter were both centers, and that's why we see true there. So the takeaway from this slide is if I compare a series to anything, in this case testing for equality, but later we'll see we can also check if the series is greater than something or less than something. What I get back is a what we might call a Boolean series. It's a series where all of the entries are either false or true, and they're true exactly when the condition was satisfied. Okay, so we call this this procedure that we're going to do that we saw a couple slides ago, we call it Boolean indexing. So to select only some rows of a table, what we do is we first create a list, array, or series of trues and falses that has exactly the same number of rows as our table. And the way to read these trues and falses is I'm going to keep the rows of the table which correspond to the value of true, and if I have a false, I'm gonna I'm gonna throw out that row. So I make that array and then I pass it into salaries with square brackets like this. Now, instead of making this list by hand, just writing out an array, writing by hand trues where I want to keep the row and false where I want to throw it out, we usually make comparisons like I did on the previous slide. So the nice thing about arrays or about series is that element-wise comparisons work as expected. So we saw this with equality, but it also works with inequalities. So if I want to find all of the rows in which someone's 2015 salary was greater than 5, I just write this little bit of code, and then I see that these rows evaluated to true, apparently these people made more than $5 million that year, and these people did not, unfortunately for them. So if I want to make a table consisting only of the players who made more than $5 million, here's what I'll do. I will take my expression, which results in a Boolean series, and then I just pass that in using square brackets to salaries. Okay, so I ask for the subset of rows of the table for which this is true. I run this, and I get back a table consisting of only the players who made more than $5 million. If you look at the salary column, you'll notice they're all bigger than $5 million. Okay. So what if I only want the Cleveland Cavaliers? Okay, remember, let's go back to one of our previous questions, like what is the total payroll of the Cleveland Cavs? Well, we might be able to answer it if I could extract only the Cleveland Cavs and all of the Cleveland Cavs. So let's try it out. So I've got a table here with a team name column, and so what I want to do is extract only the players who play for the Cleveland Cavaliers. So I will make a Boolean series. So remember, I'll get the team column. Okay, so I'm constructing this kind of I'm building up to the answer. I often write a little bit of code, evaluate it, and see what I get just to make sure it's what I'm looking for, and then write the next step in the code. So the next step in the code is, where is that equal to Cleveland Cavaliers? Okay. Now I can't really see too much. It's hidden. The Cavs are all hidden in the dots. But the next step would be to use this Boolean series, pass it into the table as so, and it looks like it worked. Okay, so I get back all of the Cleveland Cavs as they were in 2015. Okay, now what happens if I ask for something that can never be satisfied? So for example, what if I tried to get all of the players on the San Diego Surfers? Of course, this isn't a real NBA team. San Diego doesn't have a basketball team. So this condition will never be true. So if I pass this in and I ask for all of the players who play for a team that doesn't exist, I get an empty table, okay? And that's okay, but you just have to be aware that this is what happens if your condition isn't satisfied. So let's go back for a second. Let's suppose we misspelled this word, okay? And then we ran this, we get nothing, okay? We don't get an error. It doesn't say, hey, that doesn't exist. We just get nothing back. Okay, so this, if you see this and you were expecting to get something back, you might have made a typo. Okay. So let's answer some of our questions here. What was the highest, or who was the highest paid center? So our strategy in doing this is to extract a table only of centers by querying or making this Boolean series and extracting that subset. Then we'll resort to what we did last time. We'll sort by salary and then return the first thing in the index. So that means we'll sort in descending order. So first let's extract a table of centers. So remember, to do that I'm going to take salaries, I'm going to get the position column, and I'm going to run that just to make sure that that column exists and it wasn't, for example, positions. Okay, so then I check to see where that's equal to C, and then I ask for all of the rows for which that's true, and I get back a table of centers. So what I'll do here is I will save that as an intermediate result, an intermediate variable. So centers looks like this. I'm going to remove this just so we have some more screen real estate to work with. Okay, now I want to sort the centers table. So remember, I have this sort values method that'll take in a column name. So I want to sort by salary. Okay, so it's telling me I have an error. Salary is not found in columns. So what I do is I look at my table again and I say, yeah, that's right, it's 2015 underscore salary. So let's fix that. Okay, so I've got a sorted table now. Now the question, or the strategy I outlined here was that I'll return the first thing in the index, which means that I should sort in descending order. Because if you notice here, this is sorted in ascending order, and if I return the first thing in the index, what I get is poor Ryan Hollins, who was the lowest paid center. What I want is Dwight Howard, who was the highest paid. So I could just return the last thing in the index, but let's go ahead and do it the other way. I'm going to use the keyword argument, ascending equals false. And you see that'll flip things around so that the highest paid center is first. And then I want the first thing in the index, so I get the index. Okay, so if I ask for the index, this is what I get back. I want the first thing in it. Remember, the index kind of acts like an array. So I'll ask for the first thing, and I get Dwight Howard. By the way, something to keep in mind here when you're sorting. So let's take this code. Okay, ascending equals false. I can write ascending equals false. I can write ascending equals true. Notice you can't do this. Descending equals true. Python doesn't understand descending. You have to call it ascending, either true or false. Okay. All right, so take a second and read this question. Pause the video if you want. Try to figure out how you might calculate the total payroll of the Cleveland Cavs. Okay, so we've got three options here. Let's see which one might work. So in this one, I'm going to get all of the Cleveland Cavaliers. It looks like I'm going to do that here. And then I'm going to get the salary, and then I'm going to sum up all the salaries. So that looks pretty good, but let's take a look at the other examples just to be sure. So in this case, I'm going to get the salary, okay, the salary column. I'm going to add them all up. So this is adding up. I'm getting the total salary of all the players, which is a number. And then I try to, I don't know, select all the Cleveland Cavaliers from something that's not a table, but a number. So this is going to give me an error. This one, salaries, Cleveland Cavaliers. So this will also give me an error. Anytime in baby pandas that we use a table, square brackets, something, the thing in square brackets should be a Boolean series. Okay, it should be a Boolean series or a Boolean array or Boolean list. This is just a string. Okay, so I mean, it might look reasonable. It might look like we're saying get the salaries of the Cleveland Cavaliers, but this isn't understood by baby pandas. So A is going to be the right answer here. Okay, so we extract all of the Cavs. We select only their salaries, so we get the Cavs back. And then remember, series have methods on them. So if I get a column, for example, the 2015 salary, okay, I have a series. Now I can use some of the handy methods. So there's a bunch of them. One of them is sum. That'll add up all the numbers, and we saw that in 2015 the Cavs paid out $102 million. Okay, so that's selection, or at least a part of selection. We'll talk a little bit more about selection in a little bit, because it can be more complicated than that. So for example, what if I wanted to get all of the centers on the Cleveland Cavs? Now I have to do like a compound selection and get two things, make sure that two criteria are true at the same time. But we'll leave that for another time. And now we'll go into the second part of the lecture, answering the questions that need some amount of grouping.